So basically today is all about the graph stuff. So there's a few definitions that let me get to. The first one is the relative maximum of a function. The relative maximum of a function is when the value of the function at that point is higher than the value of the function at the nearby point. So for example, this guy, the function value at this guy is higher than the function value at nearby point. So this guy is my relative max. And also on this graph, this guy is going to be my relative max. So if you have the graph plotting relative max or relative min, should be a piece of cake. Relative min is, well, the value is the x value where the function value at that point is lower than the function value at nearby point. I think there are extra hands out here. Does anyone need any hands out? I'll just put them down here. So again, relative minimum should be pretty easy to spot if you have the graph. So relative minimum would be here. On the second graph, if you actually look closely, you also have this guy. The function value at this guy is actually lower. It's actually lower than the function value at the nearby point. So this guy is also my relative min. So although it's actually where the point where the function is discontinuous, but because the function value is the lowest at this point, so it's a relative min. However, note that relative max and relative min, it never occur at the endpoint. So even though this guy, the function value is higher than any point on the graph, it's actually not a relative min or relative max. And the same applies here as well. If you read some textbooks, sometimes they will actually call relative min and relative max and the local min and local max. And sometimes they will call the absolute min and absolute max the global min and max. So what is global min and max anyway? The global max is going to be the highest possible function value. So for the first graph, and that can occur at endpoint. So for the first graph, the absolute max would be here. So again, if you have the graph, the absolute max would be basically the highest function value of the graph, highest point on the graph. So for the second graph, the absolute max would just so happen to be the same as the relative max. So you get the same point there. The absolute min, on the other hand, is going to be the lowest, the x where the function value at that point is lowest. So this guy here would be the lowest point on my graph. So this guy here is also my absolute min. For the second graph, the lowest possible point for my graph is going to be this endpoint. So this is going to be my absolute min. So on a closed interval, the absolute max and absolute min is unique and always exists. However, there may or may not be relative min or relative max, or they actually may be more than one relative min or relative max. If you have, like, let's say this guy, like let's say a sine function, something like that. A sine function, you actually have a lot of relative max, and you also have a lot of relative min. So it's actually possible that you have a lot of relative max or relative min, but the absolute max and absolute min, they are always unique. So this one should be pretty simple. The Next one up is when the graph concave up and concave down. Let me see, I think I ran out of color. Okay. A graph is concave up. Sometimes, if you read some textbook, sometimes they will just call this one concave. And sometimes they will call a concave down function simply convex. So a graph is concave up if the graph lies above the tangent line. So when a graph is concave up, it has to have one of these shapes. When it concave up, there's many ways that can help you memorize. It will concave up when it looks like a U. So when the graph looks like a U or half a U, the graph is gonna we call that a graph concave up. And if you actually draw the tangent line at any of these points, the tangent line would lie below the graph, so that coincides with the definition. A function concave down if it looks like an N. So an N looks like that. So if it has an N, that also works. So if you draw the tangent line at any of these points, the tangent line will lie above the graph. So that coincides once again with the definition. Some people also said this. So concave up look like a cup. Concave down look like, concave up look like a smiley face. Concave down look like a frown. So there's many ways you can use to remember, to help yourself remember what is when the graph is concave up and when the graph is concave down. Now, if you have the graph once again, whether the function is concave up or concave down should be pretty easy to spot. The first half of this graph, you can kind of see this looks like an N shape. So on the first half of this graph, this guy concave down. On the second half, however, it looks like a U shape. So over here, the graph concave up. Now then, there's going to be a point here when my function changed from concave down to concave up. This is what we call the inflection point of a function. So the graph concave down here, concave up here, and when the graph changes concavity, this is called the inflection point. So let me try again with the other graph. The first half, well, this looks like the N shape, so this guy concave down. The second piece, this guy looks like half a U shape, so this guy concave up. And then for the last piece, it looks like a half N shape, so this guy concave up, concave down again. So we have my graph here, concave up, and then concave down, and then concave up. Let me actually write. So this guy, wait, I used the wrong color code. Okay, let me change. Show him. This guy and this guy concave down. And this guy concave up. Right. And once again, when the graph changes the concavity from concave down to concave up, then that is called the inflection point. Now, what about the last piece of graph? This guy, we have a straight line. So a straight line, it looks neither like a U graph or look neither like an N graph. If you draw the tangent line here, the tangent line actually coincides with the graph. So it's neither above nor below the graph. So in this case, we actually say that this guy is neither, so it has no concavity. So graphically, if you want to identify the relative max relative mean, absolute max, absolute mean, when the graph concave up, when the graph concave down. That should be pretty simple.